Okay, hi there, folks. Welcome to an update on the eruption now in Iceland. Today is December 19th. It is approximately 6:12 a.m. here Mountain Standard Time, so that would make it about a little after 1 o'clock p.m. in Iceland. We have had an eruption, so I want to catch you up to date on everything that's transpired over the last 24 hours or so. Look at some data, some of the graphics, some of the video. I've got a lot planned for you here. So thanks for joining me. I'm Geology Professor Shawn Willsey. So let's get right to it. As a recap, this eruption began yesterday about 22:17 or 10:17 p.m. local time in Iceland. Again on December 18th. It occurred near the Sundunukur crater road that we've been talking about, so east of the power plant, east of the Blue Lagoon, and um, north of Grindavik. And so at this time, there's no damage or impact from this eruption on the power plant, the Blue Lagoon, or the town. So that's the good news. Let's start with that we do not have any homes damaged. We do not have lavas heading towards town at this time. And so at this moment, I'd say we've got an eruption that, if things hold pat, and it's still very early in the eruption here to say this, but we're in pretty good shape right now. But we're still very cautious, and there's still a lot of things, a lot of variables that could change and come into play. Let's go ahead and look at. So this is the live view here of what's taken place, but the eruption actually has changed quite a bit since it began less than 24 hours ago. Here's another view from a different camera, and last night this whole view, and we're looking at the south end now. This is from Silingerfeld. This is a hill just east of the power plant, and we're looking to the east. The black there is the cooled lava flow. Now, even though it's black, it's probably got some hot spots, and it would still be quite hot to the touch. And Grindavik would be further to the right and out of view there. So you can see the extent of the flow. And eventually, this camera should start to swing back to the north, and you'll see some of the actively erupting areas. Here we go, it's moving now. And so, but last night, this thing was just a curtain of fire across the entire view. So the eruption is definitely waning. It has considerably dropped in terms of its output. You can actually see a few little spots popping up here and there. And then as we head a little bit further to the, looking as we swing around and track this thing to the north, we should start to see some areas where it's actively erupting. And so I want to stick with this view for a second, and then we'll get into some of the other data here. You can see that the margin of the lava flows are steaming and degassing still. All the snow's obviously melted off this section of the fissure system, and then eventually we should get to the section that is still erupting. So this was quite a long eruptive uh, distance here. We had this thing up to 4 kilometers that was actively erupting during the height of the eruption last night. And you can see that's dropped considerably. We should get to, I think so, we should get to a spot where it's just showing the active eruption there. But you can see the extent. There we go. Now we're starting to see a little bit of it here. So it's really just this northern or central part, I guess, that's still actively erupting. Now that can change moving forward, um, but that's good news because now we're not seeing lava erupting from the south end of the fissure system. So there's nice fountaining from the lava. The outputs decrease considerably. The height that these lava fountains are reaching has diminished quite a bit over what we saw last night. Last night, I think they were, and this was just my estimate, they were probably pushing 100 meters in height. I wouldn't be surprised if they were exceeding that to some degree. These look like maybe more like 30 meters, so maybe 100 feet or so in height. And then again, you can see the kind of in the with the gas there, but you can still see some of this blackened landscape as it swings to the north. And then there's a couple more little vents still active at the north end. But again, last night, everything you just saw as the webcam has panned across here, this was all erupting more or less simultaneously for several hours yesterday evening. So we'll come back to this view perhaps here in a bit. Let's go ahead and look at what this eruption looked like. The webcams actually caught it when it began. So we'll go to this site here, which has the live, it has a recording of the live from Iceland feed. And what you'll see with this camera here is the actual initiation of the eruption, and then the camera will zoom in so you can see how this thing starts as one centralized vent, but then rapidly lengthens and becomes more of a fissure or a crack, if you will, a fracture with which the magma or the lava is rising. So there, boom, there's the initial lava making its way to the surface, just lighting up the sky. And so the camera's zooming in now, and you can see the fountaining, but it's mainly just this one little vent. But now you've released the pressure, and so that causes the system to lengthen. I've got this sped up a little bit too, so if it looks like it's a little fast, I think I've got it on, yeah, 1.5 speed. I'll take it down to 1 just for a minute, but then because it's a longer clip, I want to kind of move through it a little bit quicker. So what you'll see here is this fissure will start to lengthen left and right, and that will cause the camera will actually need to back up and zoom out a bit to get it all in. So you can see some of the fountains here, the lava being shot out by the gases, piling up around the vent. There's another vent opening up to the right here. Excuse me. And that's just really hot, viscous lava, or excuse me, low viscosity lava, so very runny, and pouring down over these old craters at Sundunukur. And now you're going to start to see it lengthen, right? You can watch this one on the left side start to creep. There it is, opening up a little bit further. Now it's taking up so much of the field of view that the camera, there's some opening up here on the right bottom corner. So now it's really getting going now as this fissure system starts to lengthen and increase the area with which it's erupting from. And at some point in here, the camera should back out because it's extended beyond the field of view. And we should be able to see that. So then you can see these fountains are pretty high. Those are, again, probably approaching, maybe 100 meters or so in terms of their height. Maybe this isn't the one where it backs up. I think it was. Thought it was. Anyway, on some of the other ones, they show it actually zooming out because it encompasses too much of an area there. This might not be the one though. We'll watch for a couple more seconds. Oh, that was kind of it. So at any rate, but the thing did advance, and I did 2 live streams yesterday. One just after the eruption had begun, kind of impromptu, just on the fly, and then there was another one that I did later with the drone company Nature Eye, where we flew from the north in closer to the area to try to get a good look at it. And as we were watching on the first live stream, as we were watching some of the webcam footage, and I was jumping around like a madman, but it seemed to me as if the fissure, and this is looking to the south, it seemed that it was lengthening, but I didn't stick with it long enough to really track it. But luckily, a viewer sent me a clip that he'd put together, stitched together a bunch of the images, the webcam images, and basically showed what I suspected was true. So you can actually see that here. You can actually see that fissure extending off that way. So he's got it kind of looped there, so it looks like it's creeping backwards. But you can see it at that initial position, right? Let's watch it one more time. Yeah, so you can see it at that initial position there, and then you can see it extending to the right. So in fact, the fissure was lengthening to the south, which was perhaps a bit alarming because, that's closer to town. This is the Icelandic Met Office map. So they have put out a map showing the location of the fissure. Last night during my live stream, I was trying to figure it out, and I was pretty close. I had it as one continuous straight line. I mean, that's just what I drew. That was the easiest thing to draw. And you can see here that it largely follows the Sundunukur crater row. In fact, let me pull up I have amended my Google Earth image to show what they have on their map. So that orange set of lines is pretty close to what you just saw on the Met Office map. And so it's not one continuous line, but a set of lines. There are some stepping patterns, or what we call an N echelon pattern here. So it's not one continuous fissure, but a series of fissures. This one's the more dominant one here, and you can see the little stair step pattern. Interestingly to me is that it follows mostly the Sununukur crater row, which you can see would run this way. And then this part of the fissures align pretty nicely right on top of that. So that's the main area that's been erupting today. But interestingly, it has a little deviation here at the south end. The older crater row is oriented over here, or at least maybe it steps over here, and this one extends down into this area. So there's the more or less the 4 kilometer length that we were seeing last night that was erupting, and now it's concentrated to a little area up in the north and this little sort of middle area there. But this southern end, at least for now, has largely gone inactive and is no longer fountaining and producing lava. We'll come back to this map because there's some other things I want to discuss when we look at hazards and moving forward with this thing. Um, let's see, what else do I have? So the flows coming out of this, let's stay with this just for a second, came out to the east and to the west as you'd expect, perpendicular to the fissures. But they haven't traveled very far. They've moved maybe, again, this is just my estimate, maybe a half a kilometer, maybe up to a kilometer from the fissures themselves. And that's largely because this topography here, maybe going back to the Met Office map, the topography here is pretty flat overall. Um, and so if you look at these contour lines here, these are 4 meter contour lines each one. And so you can see that it's the contour line spacing is pretty far apart, right? Where you have these hills, these larger, steeper topographic features, the lines are quite close, and that indicates a steeper slope. But out here, other than the craters themselves, which are just locally steep, a lot of this is fairly, I wouldn't say it's completely flat, but it's low relief ground out in this area adjacent to the fissures. And so in some respects, given all the possibilities that we had leading into this, this is a pretty good scenario. The eruption started further north in the town. It didn't start right under the town. It didn't start close to the town where lava flowing into the town would be an inevitability. But instead, we have this a little bit further north. And what's interesting to me is that if we come to the southern end here, that's pretty much the southern tip, which is now inactive. You can see that there's these two hills here, and from this point southward, these contour lines decrease in elevation all the way down to the coastline. Let me zoom out there a little bit so you can see that. In fact, let's use this little feature to maybe dial in exactly, yeah, the level of zoom that we want here. So my point here is that had this fissure extended further, you can see these lines, the line spacing gets a little bit tighter, and there's a clear discernible path downhill towards the coast. Now that would still bring it east of Grindavik, but there could be little permutations that might carry it a little bit further westward. But as it stands, where this thing actually erupted, turned out to be pretty fortuitous because there's this big flat area here that this lava is just sort of ponding in. It's just not really going very far. It is flowing downhill, but it's just not moving very far in any given direction due to the topography. So that's good news. That's great news for the infrastructure. We've got no indication that any of the lava is advancing towards the power plant or the Blue Lagoon. So no indication that it's coming through any of these passes or coming around this hill here, Selingerfeld. But it's still early, right? We're less than 24 hours into this event. Let's go to the Met Office update, and this is not super current, but this was the last update they had. Excuse me, at 2:50 a.m. local time. Rather seems to be reducing the power of the eruption that started about 4 hours ago. So they're seeing a drop in volcanic output. They're seeing that reflected with seismicity and some other indicators. It's also happening, reducing activity is not an indication of how long the eruption will last. either, rather that the eruption is reaching equilibrium. So what they're saying is just because it's slowing down doesn't mean that it's going to continue to slow down and actually stop. What it really means is that it may maintain this lower state of output for some time. Let's see, anything else? Crack is about 4 kilometers long. We've talked about that. We've looked at the location, and they're just kind of still monitoring things. So that's the Met Office update. I want to show you the earthquake pattern and the earthquake data because I found this to be pretty interesting as well. So you can see the kind of mess there that forms all the earthquakes, and that's a significant uptick over what we've seen over the last few weeks when we've looked at a 24-hour run of earthquakes in this region. We've seen, I don't know, I haven't counted them all, but maybe, you know, 30, 50. And here this is showing, whoops, let me get that back. If you look at the top number, and this might be for the whole country, but obviously most of the activity is happening down here. You can see that top number in the column on the right, 452. So that's a large number of earthquakes. But here's what I want to show you that's kind of interesting. So there's the trend of earthquakes, and it's a little hard to see where the eruption took place, but more or less it would be from about here. You can almost see Hagafeld right here. So right about here, heading up to just east of this other hill up here, Stora Stogafeld. So that's where the eruption is taking place. But here's what I found pretty interesting is a couple things. So if we go back to, so this is a 24-hour run of all the earthquakes, but let's just look at let's look at the last 4 hours. Almost nothing, right, in the eruptive area. And so that's a good indicator that these earthquakes are such a powerful prediction tool. When the earthquakes are happening in terms of their frequency, that's the magma moving and breaking rock. And if they're getting shallow, that's the magma getting closer and closer to the surface. But once that eruption is begun and that plumbing system is now established, we see earthquake activity drop off. So it's erupting right now as we speak. And notice in the last 4 hours, there's been basically one earthquake along that fissure system. If we look at the last 2 hours, nothing at all. So the subsurface movement of the magma is what the earthquakes are good at tracking. But once you get that lava up at the surface, you typically they're not as valuable. Here's where they actually were valuable yesterday, and this will be a little hard to show the way that the data works here, but as we were watching this thing take place, we were seeing lots of earthquakes, but we didn't see, you can see that big orange one there, that really large one, that's a magnitude 4.1. That one didn't come in till a little bit later. You can see the time on that one, local time 23:25, so that's a good 45 minutes or so after the eruption had begun. And when I saw that, and I think I was live streaming at the time, I even talked about this a little bit. My interpretation of that, because that's a large earthquake, that's a 4, is that that's definitely not just magma moving underground. That's magma pushing and breaking brittle cold rock out ahead of it. And because this orange circle here was further south than where the eruption was taking place at that time, I worried a little bit that that meant that the fissure was going to extend to the south toward Grindavik, and it did extend to the south, but not as far as I thought it might or that it could have. So that was good. So at any rate, the earthquake pattern is really interesting because you can see how many earthquakes were happening leading up to the eruption, and then you can see how many earthquakes taking place, once this thing got started. There's 10 hours ago. Last 10 hours, 3 very small earthquakes have occurred, which is pretty incredible. Anyway, I found that pretty interesting. So little lesson to be learned there about earthquake behavior before an earthquake or before an eruption versus once the eruption has begun. The other thing that is pretty interesting is the GPS data. And so we've been watching this in my updates for the last few weeks, And what I'd been kind of tracking all along was we'd seen this is the uplift plot. This is for the power plant area. This is the GPS station near the power plant if you're kind of new to this. And so let's see if there we go. That'll make it nice and big for everyone, and I'm not in the way. So you can see the red dots are just the elevation of the GPS station at any given on a certain date, right? So this is September going into October, November, and then into December here across the bottom. And I know I'm in the way there, but it just goes up to today. So you can see this uptick right here in the central part of the graph in late October as the area was inflating, as magma was being injected into the subsurface. And then, of course, that all reached a climax on November 10th when the magma pushed its way. It left this area under the power plant. It moved to the east and built the dike, what they've been calling the magma tunnel, but basically an intrusion of magma. And that magma started to ascend towards the surface, but never quite breached the surface. So then you can see a big drop near the power plant, right? Because the magma, we have deflation here because the magma moves somewhere else. And then since that time, more magma input from below the power plant has been causing uplift. And we've been watching this uplift, and at times it was a little steeper, but it was steady, forming a pretty nice little curve here overall. And what I've been saying all along is that, that it would get real interesting when we got back to this level here. The level at which the magma moved off to the east and caused all the commotion and earthquakes and the evacuation of the town. Once we got back to that threshold, that's when I really thought something could happen. It might continue to inflate, but it would, if there was going to be an eruption, it would probably be about that time. And lo and behold, if you look at the data from the last couple days, that's right at that same level pretty much, right? In fact, it's exceeding it just a little bit. And there's that last data point there yesterday, that green one. So basically, we had magma moving back close to the surface near the power plant, and it was overpressurized. The volume of magma and its pressure with those dissolved gases exceeded what the rocks could hold, and that's what caused this magma to then break through to the surface as lava and start this eruption. So I guess I wasn't surprised. I knew that once we got to this point that the real wait and see period in terms of just closely scrutinizing this thing had begun. So that was kind of neat to see that the hypothesis that I had looked like it held up pretty nicely there. So um, very cool. So let's look at a couple other things here. Let's go back to this map. Let's look at this thing moving forward. So how is this situation going to play out? Um, we still have possibly a good long road ahead of us in terms of this thing could continue to erupt for days, certainly, possibly weeks, and possibly months. The output of this eruption was much bigger than the last three eruptions we've had in the region in Iceland. So the 2021, 2022, and 2023 eruptions were much smaller in terms of aerial extent and lava output, at least for this first period versus what we're seeing here. So even though it's greatly diminished, that doesn't mean that it can't ramp back up as more magma moves into the system. It doesn't mean that it can't sustain this level of activity for, again, weeks or months. And so just because it looks like it's winding down, I would not feel comfortable letting everyone back into their homes right away or anything like that. I think we need to watch this thing probably for at least a couple of weeks to see what it's doing and see if its behavior changes or it becomes erratic in any way. Um, so give you guys something to look at here. Oh, it must be snowing there because it's pretty grainy on that camera. Yeah, the webcams kind of come and go a bit, and I'll put links to some of these webcam images on the video description in case you want to look at those. So some good news is when we have an eruption, one of the hazards associated with any erupting volcano are gases. But the good news there is that the the wind is coming from more or less, it's moving out of the west northwest and going off to the east. So the gas coming out of these erupting fissures, all that gas is being carried either towards the coast and the sea, or into this highland region here where there's no people and no inhabitants. This road down here is closed, and then of course those volcanic gases will dissipate as they move further and further away. So that's some good news there. Is that the volcanic gases aren't going to be a problem right now. All that sulfur dioxide and some of those other gases coming out of the volcano shouldn't be a hazard to the residents based on the current weather patterns that we have. Um, so what can we expect moving forward? Well, the lava, it's going to be interesting to see how this progresses, because we know we've got some lava erupting in this little section here in this part of the crater, and some up to the north. Now the whole thing could get going again. But what's really interesting is if you look at, let me zoom in on this a little bit to give you a little better view, and hopefully I can walk you through it. So here's the southern end of the eruptive fissure. And this section is not even erupting right now. This is just what was erupting late last night. The more active zone is up here. But let's assume that we might get something erupting in this zone. So we know these lava flows are moving to the west and west and east, perpendicular to the fissure, right? The lava flies up in the air, it falls back down around the vent, and that provides some lateral force that pushes the lava towards either side of the fissure. Well, if you look at this contour line right here, it's getting higher as you go this way. So this lava could move across this big patch of flattish ground, but it's not going to go much further than this. And so eventually these lava flows can only move so far to the east, at which point they're going to get piled up and pooled in this area, but they may end up getting diverted to the south between these two hills here. And let me zoom out just a skosh, and that might help a little bit. Get it all in perspective. Pull it over here. So we have the fissure system here, but some of that could get funneled. This would be, what we don't want to see, but there is a possibility still, if the lava continues to erupt, that we could get lava, even though it's not currently moving to the south. The recipe to get it moving to the south there's two ways to get it moving southward towards Grindavik. One is lengthen the fissure and have it start erupting down in this area. And then the other recipe would just be have it keep erupting where it is, but continue that output for a long period of time such that you pool up and pile up a lot of lava. That will eventually fill in this low area and get diverted to the south here. And so then you would end up with that lava moving. Let me zoom back out again a little bit here. Sorry, playing with the map. Moving between this hill, Hagafeld, and this old shield volcano. This is a shield volcano. I'm not sure when it erupted, but it's older than the lava flows that surround it. This would be, I guess, pronounced Meathheith. So between these two topographic high points, that lava would perhaps move to the south, and then it has more of a clear path towards the east end of Grindavik, and so possibly impacting some of the infrastructure over here. Again, that's just one possibility, one scenario where we could get that lava all the way down here. So but so far it's not doing that, which is good. So that's what it would take though. And at the current rate of output, it would probably take a couple of days for it to get that far. But of course the lava output can change. It can ramp up as more magma moves into the system. We're just not sure how much. Well, we would expect to see over here perhaps, since the magma has moved over and it's erupting here, I would expect to see at that GPS station near the power plant, we should see some deflation. We should see the elevation dropping over the next few days. If it doesn't, that means that the amount of magma, possibly means that the amount of magma coming up under the power plant into that shallow subsurface reservoir is matching the eruption rate And that means this thing could go on for quite some time. So it's still early and definitely kind of a wait and see scenario as we look forward to how this could play out. Um, so I'm a silver lining guy. Well, I try to be as much as I can. So the good news again is the town is fine. The power plant, the Blue Lagoon are fine. Other good news is if this eruption keeps doing what it's been doing, especially over the last 8 hours or so, um, I think that's a good sign as well. If we can just keep this kind of rate of output in this region, then that might be good news for the residents of Grindavik. But we'll have to wait and see. I think at the same time, even though there might be some good news there, we still want to be cautious. We have an erupting volcano. There's those attendant hazards that come with that. We have a system that's not stabilized. It just started erupting less than 24 hours ago, and it can change its behavior quickly. We saw how quickly this thing went from not erupting at all with no earthquakes to producing a lot of earthquakes and then erupting quite quickly. Oh, one more thing I wanted to show you here. Oh, it's actually on this site. So this is pretty cool as well. This map.ice is great because it has really good imagery. It has the names of the landforms. There's that shield volcano I was talking about, and so there's that path that possibly exists down towards Grindavik. But what it also has, and let's see if I can do this. I did this earlier. I'm going to zoom a little bit out so you can see it all. It also tracks seismic activity. And so if we let it play earthquakes over the last 24 hours, um, so it's actually started right now. And notice there's no earthquakes. And then there's a couple, and then boom, look at all the earthquakes coming in that lead to the eruption. And I know that all happened pretty quickly there, but what that's meant to show is how quickly we went from, everything being like it was the last few weeks with no earthquake activity to quickly having that magma intrude into the system, cause all these earthquakes. I'll show it one more time here. So it's already running, no earthquakes, a couple, and then boom. And then by the time, I can't quite pause it right in there, but by the time you see, a dozen earthquakes or so, the eruption had probably already begun at that point. So how quickly things can change. So need to be cautious, need to be very aware moving forward of the situation and how dynamic and in flux it could be. So hopefully that's helpful there. And then finally, I'm going to put a link to this post here from someone's Facebook. Someone posted this on Facebook in the Iceland Geology group site. But what this has in it is the eruption, but also has some of the sound recorded. Last night on the live stream, I made a total fool of myself, as I often do, trying to play a little video clip from an eruption I was at in 2022 over my microphone so that specifically one viewer was really hoping to hear what it sounds like, and I tried to do that and I failed miserably. But I'm going to put a link to this in there, and then that person or any of the others of you that want to can go to it and actually hear it. If I play it, I'm not sure if you get to hear it, but so if you're not hearing that, you'll have to go to the link, and if you are, that's what it sounds like. Kind of a pulsing jet engine type of sound. So pretty awesome. Let's see, anything else I want to discuss or cover as we wind down this video? Moving forward, I'll certainly provide more updates as things progress, as I feel they're warranted. So if there's more things to look at and discuss, I'll certainly jump on. There's also, there's a lot of other places you can go to get this information. The major media outlets have obviously picked this up. There's all sorts of folks with their own YouTube channels and that sort of thing. And you're welcome to go where you want to for your information, but I do appreciate you coming here. I try to give you a nice measured approach to things with my scientific analysis. And also, I'm I'm not a big hype guy, so there's a lot of clickbait out there. I try to avoid that. It is erupting. That's exciting. Um, the town's not threatened. Yes, the town's evacuated, but this thing played out pretty well if you think about it. I mean, the November 10th event gave us some time. It showed us that there was an imminent threat to this community and the power plant. Um, we were able to get people had time to get their belongings, their pets out of the area. We had time to erect a fortification around the power plant, and time will tell as if that's going to be effective or not. Remember, it's not really stopping the lava; it's just redirecting the lava around the power plant. That's the whole premise of that structure. So we'll have to see if that works. But the good news is we had a little more than a month to prepare for this thing. We knew something was likely to happen, and here it happened. And so even though you might have got some people might have got frustrated with the scientists, and they don't know what's going on and when's it going to erupt and predicting, realize that that's just not the way it works. We're not able to accurately say where the magma is going or what's going on. But I think as a scientific community we did a pretty good job with this one. We recognized the danger. The area of focus that we'd been looking at stayed the same. I had certainly been looking at this area as the most likely area of eruption, more or less since the onset, just because that's where the earthquakes were. And the earthquakes generally are pretty good breadcrumbs that show you where things might be happening. But we had time to get people out of harm's way, and the eruption has happened. And so far, there's no lava in town, which is great, and we hope that that stays the same. So right now we just have a nice eruption to watch on the cameras, and maybe it'll stay that way. Let's hope so. But I feel like the as a community, as a civilization, we've done pretty well with this thing. The science did its part, taking that data, which is not complete, which is not perfect, making the best inferences from that data, modeling that data, communicating that data to the public officials where they can make the decisions of what to do with respect to public safety. Those people responded well by heeding those warnings and those directives, getting the town evacuated, getting their belongings out of harm's way. So it's in terms of disaster preparedness, I'd say it's a rousing success so far. Doesn't mean that there can't be impacts on infrastructure, but so far this has gone really well. So with that, I'll sign off and I'll keep you updated on anything else going on. Appreciate your viewership and support here. Hope you're doing well. If you're celebrating the holidays, happy holidays. And otherwise, just enjoy the eruption and stay tuned. And we'll talk to you soon. Take care.